You have to understand that the generic model of IO is like this. The IO contains this is the IO module, and this is the link between the peripheral devices, and then we have the connection with the computer system, that is outside computer system, through the address line, the data lines, and the control lines. This is how to the computer it is basically connected. Then I told you internal, this is the internal block diagram of an external device which contains a control logic, buffer, and transducer. So control logic, you can see that the control signals can come from the IO module to the control logic, and from the control unit logic, the status of this device can also be given to the IO module. Now through the transducer is where the interface between the data transferring happens between the external environment to the transducer, and through the buffer is the data is transferring in bits from the buffer in and out to the IO module, and from the device to the IO module, from the IO module to the device. Such data transfer is happening from the buffer part, as you can see here. Now if you consider keyboard or monitor, in keyboard or monitor, the basic unit of transferring here is the character. The basic unit of exchange between them in the keyboard and monitor and all is the character. And in the character, each of the character you can write it in a 7-bit unique binary form. You can write 7 or 8-bit unique binary code you can write. Now that is basically IRA, that is International Reference Alphabet, is the standard character code. And using this, each character you can write it in a unique 7-bit binary code. Also, if you have 128 characters, you can write 128 characters can be represented using a unique binary code. Then there are two types of character that you have to understand. The characters can be printable characters can be there, and control characters are there. Printable characters are those visually you can see, but control characters behavior is only what you can basically see there, like new line, tab, backspace, other control characters. Fine. Then when I'm talking about the next thing, disk drive you have to understand that in disk drive what is happening is that there are two electronics which are simultaneously working together. One electronic is used for the communication with the IO module, like between the data part, control part, the signal part, and there is one electronics, and the other electronic is used for the controlling the disk read or write mechanism, right, which controls the physical read or write hardware. For that we have another electronics. So the disk drive, there are basically two electronics here. One electronics which basically handles communication with the IO module and all, and there is another electronics which basically controls this read or write mechanisms here. Okay, now there are fixed head disk also is there, and movable head disk also there. Fixed head disk means the head is actually fixed there. We cannot move that head. So here what is moving, that the disk, the disk which is there, the surface would actually move. So what happens is that while this moving, the transducer would take this magnetic patterns from this disk surface, and it will convert it into what, the bits which can be stored in the buffer. And during the writing time, the bits which is present in the buffer, that can be converted into the magnetic patterns which is present in the disk surface. That is in the case of fixed head disk. When I'm talking about moving head disk, in the moving head disk you can see that moving head disk, what happened is that the hard disk drive, right? Here that the one arm is there, in its tip there is head which can sweep across the surface to reach to the correct track. So in here, addition to the read and write, here there is what, mechanical complexity is also added additional to that. Now we are going to talk about the main 5 functions of our IO module. The first function is the control and timing. Now the CPU would require this IO module, and when it requires and is unpredictable. The CPU can require one or more IO modules it may needed, and the behavior in which it needed, it doesn't have a scheduled time and a fixed schedule and all is not there. It is not there. It would access when the program needs it. When the program needs the IO module, then that time the CPU would need the IO module. So at that time, the system bus and the main memory, like these shared resources, will be doing some other activities there, right? They will be doing some other activities. So this IO module would basically control when would this device would get access to the shared resources, and prevents the conflict, and make sure that the data flow is happening in an orderly manner. This is done by the IO module. Now how the data transfer sequence is happening here is that first the CPU, what will do is that the CPU would ask for the data. First the CPU would ask the device status. So what happens is that the IO module would then give would reply with the device status. When the IO module get the device status, and if the status is ready, then the CPU would send command. Now what command it sends would be different. Sometimes data transferring command it will send. So what happened, the IO module would then interpret that command and transfer the data in units, that is 6 or 18 8 or 16 bits it would transfer, and the data is transferred from the IO module to the CPU. Okay, the next main function that it do is processor communication. Processor communication means we have to understand that the processor would send some commands. Okay, that commands would be interpreted by this IO module. Now where the processor would send this command to the control bus, and from the control bus the IO module would interpret that command. Okay, for example, if you consider disk, read sector, write sector, seek a track number, scan record ID are the different commands that the processor can give to the IO module. Now if the data has to be transferred, that data exchange can happen with the help of database between the processor and the IO module. Now I told you the IO module would also give the processor the status. It will report the status, whether the device is ready or whether the device is busy and all. Now we have to understand each of the peripheral devices connected to this IO module has a unique address. So whenever in the address bus, if it sees its own address, only the IO module would respond. Otherwise it won't respond. Like when you hear your name only you will respond, like that. Now the third main function is device communication. Like processor communication, device communication is also happening. It involves different commands, status, and also data transfer commands and all is involved in the device communication also. You have to understand that while the device, that is you have to understand that here our IO module is like a translator between the processor and the device. Like it can speak both languages, the language of this high speed processor CPU or the bus, and also the language of this slow device specific. Each of the peripheral device have different language, so it can speak the device specific language also. So that is one thing happens in device communication. And the fourth function is the buffering, data buffering. That means we have to understand that the data buffer is a small temporary storage which can store up to 8 to 16 bits and all. It is present in associated with this transducer actually. Now it's an essential task here, that is the data which is coming from the main memory can go to our IO module in very fastly in a rapid burst. So here the data would be buffered, and when the data is buffered, then only in the peripherals device speed only the data you can give. So the IO module would then send data to the peripheral device at its space, at its data rate. Okay, so the speed of the IO module and the speed of the device is different. Main memory speed we know it is like in nanoseconds, and the peripheral device speed is in milliseconds. So what happened to smoothen out, to abstract this difference in the speed, what happens is the data is buffered. For example, from the main memory, I told you, from the main memory the data is sent to the IO module. So IO module, what it will do, it will buffer this data, and the data is sent to the peripheral devices at its data rate. Means output means what? Memory to device, external device I have to give. So if I want to give from memory to the external device, then what happens? Memory would give it in a very rapid burst. It would give to the IO buffer. Then after buffering has done, at device's space, at a slow data rate only we will give to the device. Now input means what? From device I am giving to the memory. So from the device it will reach the IO buffer at a very slow rate, and from there at a rapid burst you have to give to the memory. So this would absorb this speed difference to the IO module. So this is what I told you about the data buffering. The next main function which is done here is that the last function is error detection. This IO module can detect the error and report the error to the CPU. There are two main errors. While transmission an error can occur, and the next is the error because of electronic or mechanical device error. So that is when the hardware failure occurs, the device can detect that, and it would report that to the IO module, and IO module then report it to the CPU. Okay. Now if there is a transmission error because of the let's say noise or interface and all, what happened is that our bits can become flip. It can flip our bits, 0 become 1 or 1 become 0, like that. So there is error detecting codes like parity, and we can say CRC, that is like cyclic redundancy check. So these are the codes which would be help. It would basically detect that the receiver has received an incorrect and the corrected data it received. So it will detect that in that way. Okay. So it can it can flip the bits. So here basically because of the noise or interface, this basically happens here. So these are the main functions of our IO module. Thank you.